Good morning, everyone. Good morning, all the participants. We are just waiting for a few moments. Our resource persons are yet to join. They will join in a moment. So once they join, we'll start the program. Thank you for your patience. Please bear with us. Good morning, sir. So are you able to hear me? I'm not able to hear you, sir. Good
Send
morning,
the link
sir.
again to my WhatsApp. It is not getting updated. WhatsApp
Pardon,
में
sir?
link दोबारा भेजे.
Okay, sure, sir.
I have
Good
joined
morning.
mobile, but not getting. Yeah, ठीक है. आगे. WhatsApp. It is not getting updated. WhatsApp
Pardon,
में
sir?
link दोबारा भेजे.
Okay, sure, sir.
पासवर्ड क्या है? पासवर्ड.
Sir, password is 2022.
मेरा ईमेल एड्रेस कौन सा है? जीमेल और NIC मेल.
सर दिस इज अटेंडीज लिंक, सो कोई जरूरत नहीं हो पड़ेगा. मैं आपको पैनलिस्ट बना दूंगी.
पासवर्ड क्या है?
So is my voice coming?
Yeah. I'm getting your voice, but it is in use. It is requesting for a password, even password. मेरा email address कौन सा है? Gmail और NIC mail?
So this is a attendees link, so कोई जरूरत नहीं हो पड़ेगा, मैं आपको पैनलिस्ट बना दूंगी.
Password क्या है? It is asking for password. Yeah. I'm getting your voice, but it is in use. It is requesting for a password, even password. मेरा email address कौन सा है? Gmail और NIC mail? So this is an attendees link, so Okay, I'm audible. Your audio. Audio not visible.
Sir, Dr.
No, it is
Shweta
okay.
is just
No,
joining.
it's okay.
There
Am I
is some.
audible?
Yes, sir, you are perfectly audible. Dr. Shweta is just joining. She is facing some technical glitch.
Okay. Okay.
She's just joining in a while. I think she is here.
Yeah. Hello, Bhopal.
Yes, sir.
Is it? I think maybe internet problem there on her side.
Yes, sir. Yes. Sir, just
You made me host, but I have changed to you because you are the host now.
yes, sir. Actually, she had to leave because of the technical problem. She's just joining back. I'm so sorry for the delay.
You can start. You can just give a bit of introduction and then we can start.
Okay, sir. Okay. Just give me one moment.
It is already 10:16. You keep on speaking to the participants, no? You just tell something about an NIDM and other things about the program.
Okay, okay, sir.
You keep on continuing because participants may. Or shall I go on speaking something? Huh?
Sir, I'm just starting. Just one moment. So, very good morning to all of you. I am Dr. Kopal Verma, Junior Consultant with ECDRM Division of NIDM. I am so sorry for this delay and because the actual host of this program is actually facing a technical glitch. So once again, I welcome all of you to this webinar on industrial safety and disaster management. And today we are grateful to have Professor Chandan Ghosh sir with us. He is a professor at the Resilient Infrastructure Division of National Institute of Disaster Management. So we are so happy to have you here, sir, and we are looking forward
Thank
to
you.
listen to words of wisdom from you, sir. So over to you, sir.
Okay, thank you, Dr. Kopal. So welcome to this program, which is of course going on weekend on Saturday, but still online system that keep us connected and keep us working. In that industrial safety and disaster management is very much known to us. I would like to have some of the things that we need to take care from the disaster mitigation point of view and preparedness point of view. I can share my slides. I'll show few video also and a few slides, so maybe for 25-30 minutes. Is it? मेरा slide visible है?
Yes, sir. Yes, sir. It's visible. Can you make it full screen, sir?
Yeah.
Yes, sir, it's visible.
This is the topic I have chosen here out of so many things that we happen to see, whether it is natural made or whether it is industry. There are a lot of accidents happens. Of course, they are to happen, but what kind of preparedness that we have to take? And at the same time, when accidents happens, of course, they are rare most of the time. All the industries, whether it is thermal power or whether it is food processing industry, whether it is refineries, wherever the chemical, say processing or fertilizer industry, there are several industries are there. But now time has come, not that only counting the number of events that happening, whether it is oil fire, oil tank fire, or even in NTPC nearby here, boiler got burst. So that has given us an step to take forward, that how to assess them before they go wrong. So what are the kind of health grading system for the industry, for the other kinds of infrastructure, because it is all related, whether it is railway, whether it is transport. Now you know that country is facing serious crisis about the coal to run the thermal power station. So many of the trains got diverted, passenger train, to bring coal to the say thermal power industry, because there are some lacuna or some kind of systemic fault to reach the coal to fire them, and so that to get the electricity out, which is in high demand. Of course, this is a season. Now, preparedness and other things, in fact, when, yeah. Anything?
हाँ वो रिकॉर्डिंग जो होस्ट रहेगा ना
Is it okay?
Yes sir, so sorry.
No, it's okay. So industrial safety is not that only to look after the industry that after it went wrong, but now I will show some of the measures being taken up elsewhere in the world, and at the same time, whatever existing things are there, so how we can take note of that. In that, again, my share button has gone. Shall I share again?
Reshare, yes sir, you'll have to reshare.
Okay. Okay. Is it okay? Can it
Yes
be
sir,
seen?
it is. Yes sir, yes.
Okay. So just to again to continue with that, how an industry or health or a port city or an entire industrial city or that like we say small economic zone that came up more than 10, 15 years back, how as an industry or industrial complex that which are created in many metro cities, but they are now being shifted. But like in Delhi, we are having many industrial complexes are there. How the grading to be done, apart from the buildings, but what are the process of grading? Just only I'm showing, not going into the process, like ports. Port is given a C+ grade in USA. The kind of grading system that they have started. A port overall, so many infrastructures are there. So many things are there. You see, it is one way or other, in a multiple way. It is when something is made for our living, whether it is a high-story building or it is a chain or supply of goods from port to hinterland, or even vice versa, or from port to port, or from different countries. And in fact, you see that it is given a C grade in USA, one of the port, that port, and similarly, they have got that categorization and such kind of grading for about 19 categories
It may be railways, roads, it is dam, it is even national park are being graded. Even cities are being graded. So in that case, industry also to be graded, being graded by a professional agency. So looking at that, how this C plus grade is given, and you know, grading, how C fares well when a grading system is A or A plus, or sometimes A plus plus, then B, B plus, or B minus, whatever grading system that we are familiar with from the school to the colleges and university. So C means it is good, or even little bit above the average, or whatever it is. So now, what are these grading system and how they are decided by many of the experts available? Like for that matter, here only industry process part has not been involved. Here only from the civil engineering point of view, that whatever port infrastructures are here, jetties and other things, and then buildings and everything, but it is only this portion. Only overall picture is showing, but only this portion over here that they have graded separately based on the thousands of parameters which they have set. I'll come little bit of that detail little later, but only just to show the first instance of how a port is being graded, or railway is being graded, or even airport is being graded by such kind of assessment grading, like C plus for here. But before going into this subject, I would like to know that this is something that a nature's creation. In fact, a tree, you know, banyan tree, or whatever we call in locally people, or in our own language, many ways that we know, and that what is the size of this, and how 1, 2, 3, and 4 is this one, how these are coming from a stand like this, and the height of this is more than 20 meter. Each of this branch is 20 meter. But if you ask me as a civil engineer, like grading system that I'm talking about the building only, infrastructure only related to the port, at the same time, when we look at all that, how for 30 plus years, this tree is posting three branches of it, main, and all the three coming, protruding from the same place, and another just a few 1 meter maybe, or less below that, another one of equal spread. And what is that joint, and how it is holding nature wise, and each and every leaf, thousands of leaves are there if they are to be counted, how they are equally bright in the sunlight, survives where we are not putting any water. It is just a photograph taken from the rooftop at the fourth floor rather, taken this from the above, and whereas we have the roof garden where we give every day several liters of water to make our plants survive, whereas we don't take care of anything. Everything is fed by the nature. But what I mean to highlight there, how to grade the work, how to grade this tree as that which is giving so much of say shading, and it is standing tall, and how to grade this. Do we have any grading system? Well, we have graded system in our colleges, universities for the industry, and many processes, and we have many direct, indirect sensors, scanning. I will come into that little bit of that. But there is no such grading system and even from the mechanics or our engineering mechanics point of view also, we do not have any principle of engineering mechanics to explain the robust standing of three equally robust branches of say 20 meter high, widespread, and holding from the same girth over here. And in fact, we do not, there is no such grading system, or whether it is good or bad, or rather whatever we understand, as a science, or in science, mathematics, applied mathematics, or engineering or mechanics that we define, it is not definable by any mechanics for that matter. That is what just I wanted to say. So this tree is having so many branches extending their wider network so gorgeously and strong enough for a lifetime, say beyond 100 years. It is more than 30, 35 years now. And it is so well intact with the ground, requiring no water or any food from anyone like us. Yet it is wondering how, defying our understanding of frame structure, like buildings and other things that we do, that we have known from the rudiments of civil engineering discipline. This example, unparalleled, yet not proved by any mechanics seemingly known to us as on date. So, industry requires assessment, such as use of these days, a lot of discussions will be taking place with the next speaker, use of advanced AI for condition monitoring, process optimization, and asset management. And asset management, industrial asset management, and then bearing and sealing solution, the kind of bearing and sealing solutions, and there are many kinds of such solutions and chemicals being produced to maintain the functionality of any rotating machine, because machine means there will be some rotating parts or some eccentric parts or some kind of moving parts will be there. So in that case, what kind of important, industrially, like grease, we put grease in our car or cycle and other things. So there are certain such kind of admixtures or greases being developed, which are so well, I mean, there are some products available now that you don't need to grease for a car, even the tire or anything, for maybe next 15 years. So it is a kind of development that has come up, like battery. Now, small pencil battery can give power. Small pencil battery, say AA, can give power to our devices, which I am going to show, for 20 years without any change. Whereas a normal battery, which are available now 15 rupee, maybe if you are using in wall clock, 1 year is more than enough. But same battery now being developed, that which can sustain or give on, keep on moving, or the clock for 20 years. So that is a kind of development has taken place. Similarly, in such area, of course, details I am not discussing. I'm just taking some of the things that were to survive or to maintain the industry well. Now, to maintain the industry's efficiency and scanning of their current health condition and how long that they are going to keep on production process that without any interruptions, that has now been enhanced by some of the like bearing greases or some kind of solutions that which are to be provided into the rotating part or into moving parts. Then shaft alignments and geometric alignments, they may get disoriented during the process or manufacturing. So in that case, those alignment with the help of AI and scanning machinery, whether even a micro movement of that or eccentricity or because of the wearing tearing, the machine may go out of order from the desired life or desired life of its say functioning. It may get reduced drastically until and unless we keep on checking that certain standards, industry standards are there, the process and machinery standards. If they are wearing or tearing or moving this way, because everything is moving there, if foundation is not good enough, or foundation get deteriorated, or it is affected by some external forces, it may be a flood, or it may be earthquake, or it may be any of the natural or cyclone or something. Because of that, if alignment goes wrong, but still machine starts operation after maybe few days or few months of non-operation because of such kind of external effect or internal effect which may cause, even without these external causes, that needs constant monitoring. And that monitoring is being done, of course, by each and every industry. Otherwise, you would not have got, otherwise, the kind of number of even MSME or small scale industries are there. There are several lakhs of industry every day and night they are operational. So whether it is sugarcane industry, whether it is you say food processing industry, it is going on, and machine have been devised to give its proper output. Even tractor has got some service life, but proper care and maintenance has to be done. And so how to keep check? These days when we take our car to garages or say Honda or whatever there are some computerized scanning is being done. Wheel balance movement is being checked. So which are industry standard being developed as and when we are shifting and making progress from industry 1, 2, 3, 4 now. Then engineering changes of rotating engineering changes, so some movement, some kind of eccentricity, some tear, wear, or some kind of shifting. Then of rotating equipment for better performance. This is to be checked in the name of, assessment or health assessment. Ensure zero surprise failure of equipment through advanced analytics. So here again, AI, VR, or augmented reality kind of things are there. Through AI, they are checking, like CT scan is being done for our entire body or brain or whatever portion that we want, and it is being reconditioned or it is being reconfigured into a 3D so that it helps robotic surgery or the surgeon to do some kind of very minute surgery or very much tumor surgery. They have to take out, scoop out that particular portion, which is now being augmented through say several slices of CT scan, and through a very highly sophisticated software, they are reconfigured, reconstructed into a 3D where every micro level, even our nerves and everything are being identified, and they have got that a lot of establishment now these days. So whether it is medical industry, again, not the industry we talk about, the patients and other in their relation or medical tourism, but in the medical industry, there are more than 10,000 tools are there, whether it is scissor or cutting or needle or wear or whatever it is. There are more than 10,000 plus items are there, which is required by the medical professional to use them while doing even a surgery on any part of our body or even to the animal also. So in that way, when the complexities are more, so have been the coordination, like whether it is connectivity, data, computational power, or it is analytics and intelligence is being involved in the industry 4.0, then human-machine interaction, that it is vice versa, that virtual and augmented reality, robotics, automation, collaborative robots, augmented, GBs, RPA, chatbots, and all these things we are now getting integrated into our system. And of course, advanced engineering is there. So, but what is happening is that in many of the cases, while in the name of disaster management, we are doing a lot of services, made a lot of guideline, and in fact, NIDM has developed a number of Professor Anil Gupta and his team, a lot of contributions on the various industry safety related rules, law, regulations, and guidelines. And handbooks are also available in our NIDM website. But what is happening is that while taking from disaster management or disaster risk assessment or disaster impact analysis, or like we say, environmental impact assessment. Similarly, we try to feed in something like disaster impact assessment, which disaster happen, impact assessments later. But now the topic here or the aspect here we are looking at that is industry, before they go wrong or before such kind of things, ensure zero surprise failure equipment through advanced analytics, and the kind of standards that being developed, whether it is water supply or whether it is gasoline supply through pipeline, thousands of kilometers of pipeline where leak detectors are there, where various such handy tools are available and which are known to the industry, and which are pressurized fluid are being flow from one city to another city, underground, overground, storage. So many facilities are there. So when those are being done, monitored, where leakage has occurred, that can be detected and that can be repaired before they go wrong. At the same time, the importance of checking or surprise failure like this is also one of the standards or industry standards being taken up now, that how long it is going to survive and whether there is any check or on the process that were continued negligence or that occurrence, the way that disease happens in our body, it doesn't happen overnight. It will give certain symptoms. So those symptoms are being analyzed and checked, and which is catching up. Many of the advanced organizations are now having such kind of equipments. Most of them are available from abroad. My next speaker will tell detail about that. So now let me come that what is going on, that just only it is taken from Dr. R.K. Bhandari, a book published by a Joyride for students and teachers. What is disaster education that we are looking at? And you see that with the blindfolded, we are taking some like participants over here. Of course, I know that the context of these participations and the kind of awareness, goal is awareness, not looking into the too much of AI or too much of industrial processes. But what is happening is that our role is to get people aware from bottom to top level. But the process of getting people, community aware is something like that. Sometimes there is a huge gap is there. So such kind of organization or such kind of seminar makes us to help to make a bridge over here, at least not that it is not possible to jump from here to there, but some bridge will be. So this one gives a confidence that even if it is blindfolded, but at least follow this way with certain directions and other things. So it is just only in a nutshell I wanted to say. So while making flood walls, like I just take an example from other side, there may be many processing industry over here. Ultimately, flood, landslide, earthquake, fire, forest fire, so many things are there. Of course, we don't make any such kind of heavy industry in the forest that which are liable to forest fire. But in order to saving industry, whether it is a building industry over here or some plants or something, we need to take some preemptive measures, some mitigation or some preparedness, something that happening every year, whether it is flood in Chennai or Bangalore or even Kochi airport or Calcutta, that even many times our Delhi airport also got inundated due to the heavy rain. Most of the time rains doesn't happen only on the spot. They come from externally also. So in that case, what kind of instant measures that can be taken so that the extra water comes? These are the instant measure that which can be done by anyone to channelize the water through this so that they do not inundate or come this side. They do not come this side. So in that case, we have to take just only like this is coming this side. This will be stopped. Then whether it is a building or multi-story building, then only a wall is saving here, only this wall. Only this wall is the saver. So this water is prevented from entering into that. Very small measures. had not this wall being properly maintained with sealants and other things, it would have made a havoc to the functionality and damages that it would have caused over here. So there are certain small measures, not but important non-structural measures to be taken to save the industry, or even by putting this some kind of, say PVC, some polyurethane, say material that which stops water from one side to another side. It is not going there. So in that case, what I would say that okay, so it is something. It is being stopped over here. So such kind of stopgap measures, instant measures, can save a lot of things from the downside over here. Or even some kind of barriers over here. You can think of that some of the many aircrafts in Chennai airport, which are costing more than 100 crore, they got inundated, or they are aircraft inside the aircraft water, and they were standing with the equally high air water. You know that if 100 crore property like aircraft is having so much of water into that due to this instant rain, then you can think of that what is the kind of damage and loss that we have to incur. So in that case, now such kind of barriers are there, which are very easy and quick. Even we can surround an aircraft even up to say 2 meter, 3 meter height by this kind of barrier instantly to save 100+ crore property. 100 crore property here that to get inundated, something like that. So such kind of things can be done. In fact, even some of this, you see, this vital property are being saved by making such kind of temporary structure. So this is something just to say that not only that industries are established at a prominent place, but there are certain events due to climate change or some of the events, flash flood is happening everywhere. So flash flood or even earthquake can come anytime. So in that case, some of the measures like I have given here, in order to save in industry, then it is not that whether our machine plant is functioning or not, whether CT scan has been done, as I have been telling, but at the same time, we have to see that in the nearby facility or area, is there any chance from some external threat, like it is here shown in the form of barrier, putting some kind of barrier from the flood water entering into the industrial plant. So infrastructure rating in that case, you see 2021, they have graded. Here it is 6, 12, and 12 plus 5, 17 such, whether it is stormwater, roads, port, like C+, as I have shown in the first figure. Then hazardous waste, dams, then energy, like solar energy or thermal power, so many things are there all together. Rail, solid waste, wastewater, and then transit, like there are so many transits are there. Then schools, public parks, national park, like that. Inland waterways, it may be canal structure or elevated, piped supply of water, or drinking water system in a city, or in that now drinking water is being taken up in the villages. And then aviation, all have been graded. You see, none of them have got above C. Can you see here? No one got even B. D also is there. So this is the kind of grading that California infrastructure, California, USA, California state. So all the state, they have got their infrastructure rated by professional agency by this way. Of course, there are lots of details are there, which I think I cannot take. The American infrastructure scores, overall score, C, D, and B, nobody got. Overall score is coming as C-. And in fact, there are a lot of details you can see. Infrastructure report by American Society of Civil Engineers, and historic $1.2 trillion budget by Congress for the next 5 years given in November 2021, based on the report submitted by one of the professional agencies, very famous in civil engineering, about all those infrastructure. There are 17, or in fact, there are 19. For California, it is 17, but for the entire country, 19 such infrastructure they have taken. So there are about 30,000 miles of inventoried levees across the US, and an additional 10,000 miles of levees whose location and conditions are unknown. Despite they have taken 19 such infrastructure category, but a lot of things they are still not able to do, which they have been doing since 1988. So what I wanted to highlight, the kind of importance that given, of course, in our country, we have earmarked National Disaster Response Fund, and Recovery Fund also is being given. So with that financial mechanism and a lot of things are going on, but it is all on the response. And of course, now disaster mitigation has come, but it has not been categorized so far in a manner that which is being shown over here. Even though grant has been earmarked, but it is up to our role here in the disaster management, where we have to develop this categorized information about the infrastructure and their health condition and the kind of capacity or preparedness, and taken their checking, scanning, and with the industry 4 level of sophistication between men and machinery, then with the data, AI, everything that we have to do. So these are all, category that they have made, upgraded to C- recently. And these are all, 1988 onward, what kind of grading that they have been giving. And cost to improve is 4,509 trillion, 4.59 trillion, 4.6 out of that 1.2 trillion in 2017 here, but now it has increased like anything. Now it has increased by maybe twice. So out of that 1.2 trillion that they have delivered based on the report, and what are the basis of making those reports is also very important, and which is there in that report, which is available freely. You can see into that. Does the infrastructure capacity meet current and future demands? Then condition, funding, featured needs, operation and maintenance, public safety, resilience, innovation. What kind of innovation has to be done? Now, AI has taken over in many things. So those are the innovations to be brought in. So like whether it is a grease that to maintain the efficiency, functionality of a rotating parts in a machine, it is lots of research have been done. And based on that, the grease that which is being developed, that which is developed in other country, but which is marketed now in our country, that which can give life, say protected life, not only that every 6 months we do our car getting checked, that change the oil and filter, but now with this kind of added things that into the rotating part, it gives much more functionality as well as efficiency to our process or machine, be it a car or any other things. Even dams, they have rated C-. So I'm just going a little first. Even the roads, they have made D. You see that such important roads, and so gorgeously the roads are there. They have given D grade. Who can challenge? Because in some of the roads, they have taken the weighted average of all the road conditions that which is there in USA also. So what are the types of industrial weights? This, even in the manual made by NIDM, you can see all these wastes are there, and batteries, lubricants, now lithium-ion batteries are coming up. Even many of the Indian startups are coming up very brightly to make next level of battery for our so many e-vehicles. But the kind of things that we see even in Yamuna sometime, where in Delhi, also that what kind of safety that we can ensure. And even though these are there, but we keep or we leave it to the nature. But now a process has come to clean this water also, without not in a conventional way, but by natural way. Of course, I'm not going to discuss about this. This water can be also cleaned in situ here. So think of that, the kind of industry that we have made, whether the leather or tannery industry in Agra, Kanpur, that what kind of toxics products that they are giving, government and even many of the multi agency plus other countries, they are giving grants to mandatorily through NGT, through Supreme Court, that whatever is coming out as an effluent, that is to be checked. And for that, again, specific measures are being taken. A few projects are going on. So even whether to extract curcumin from this nature, like haldi, or making it into, or even some kind of hydroponics that which are going on across the world, it is really marvelous that to bring the nature closer to us and make whatever industrial process that go on, the waste that I have given the list over here. Of course, there are certain way that we are now taking up to make this our industrial effluents that making us sick or making the environment and water, soil and drinking water, everything polluted, then there are some ways to replenish that. So, of course, now I think I should, I should end over here because IT and other things are there, information technology, LoRa. Now in Delhi also, we can get connected by wireless devices. Recently, we had some of this seminar, direct practical seminar, that how wireless systems like LoRa or LP1, low power wide area network system, that we have been able to connect. And in fact, it is going to 5G auction is going to come maybe in another 2 or 3 months, which is almost 6-7 months early than what was projected few months back. But this is going to take up a quite significant step in connecting, communicating wireless and through a dedicated radio band 857 to 859 earmarked for India, that which are being used to collect the data and take immediate action if something is going on wrong. And many of the things are going on in this area also. And of course, with Internet of Things and LoRa technology, connections and checking and then getting the data and take appropriate actions are the things. And in fact, IoT in our markets, we get intruder alarm bell, or we get even at the cost of 85 rupees, we get all these things also. And we get a lot of things, LoRa panic buttons. In fact, we had a practical demonstration a few days back in one of the webinar in NIDM. And then COVID sensor, even carbon dioxide monitoring also can be done. These are the devices being assembled here, but all the work and technology and everything done in Germany, Netherlands, another place. And they are so robust. This is a small size. That even they can take 4-ton load, and you throw it in water or swimming pool, wherever it is. They're all watertight, IP67, and there are lots of such quality standards are there. So, and it has got a battery which can survive or give on supplying the data, collect the data, store the data in the same thing for even 20 years. That same battery can give air quality sensors and everything. So the amount of money that we are spending, that like innovation, the last part that I have shown, amount of money that we have spent in establishing some of the air quality things that in Delhi itself, Delhi NCR, more than 30, 40, even 100 crore that we have invested. Now these are being done in few thousands also by putting such kind of devices, whether in the car or a building and school, wherever it is, and we get more distributed value of air quality. Not that it is different in Basant Kunj, it is different, it is very high near airport. Those kind of information can be collated more substantially by using small devices like these, which are distributed across the state or wherever it is, across Delhi or other place. So we get more sensible as well as corrective method of getting this air quality data. Even carbon dioxide also, we can check it. These are portable, doesn't need anywhere, no electricity, nothing. Anyway, I think I have taken too much of time. So I would say that even what is the industrial process for making such kind of mask? They have got some industrial marks over here, and which are majorly got neglected, because we go to the market, buy N95 mask, even for 5 rupee, 10 rupee, put that, emboss it and get it. But in order to get a quality mask like that, which needs lots of, such kind of industrial process, which are hardly developed in the country until and unless indigenously. But of course, this process, the way that we are manufacturing mobile across mobile, that we are becoming #1 in mobile manufacturing, based on the design and everything made outside. So same way, in order to make an N95 mask, we don't have to reinvent the wheel, but we are becoming a manufacturing hub like that, like for the vaccine also. Anyway, there are many innovations are here, transparent things are coming in the market, and also the way that quality check, these are all industry, that whether these materials are available or not in our country, we still have to look at. So thank you. I don't want to add any more thing. I've taken too much of time. But at the same time, just last but not the things that we are very much becoming technology savvy, whether hand washing during COVID is perfect or not. Of course, we have given that 20 seconds or you have to keep it and something like this. But again, there are some scanner to check that whether hand washing or not. So we are becoming techno savvy with lots of innovation coming up. But now concern is that lots of radiation, electromagnetic radiations that are taking place through Wi-Fi, through our mobile. So we have to again protect our mobile and house also with anti-radiation devices. So this is the thing that I wanted to convey. Thank you.
Thank you so much, sir, for your wonderful deliberation. I'm extremely sorry that it was a technical glitch actually there at the starting, but you have wonderfully explained all the nitty-gritties of resilient infrastructure, which is really, really development and really, really important, because nowadays, wherever we are going, especially in present days, we are seeing that all our infrastructures doesn't have much life. You know, the life is for 40 years or 30 years or so. So it is really important to understand that how to make our infrastructure resilient. Like Metro Rail Corporation, they are saying that we give the life for 100 years. So actually we should achieve that for everything. So before we leave, sir, I would like to mention here to all the participants that Professor Chandan Ghosh is one of the learned professors of National Institute of Disaster Management. So he is a civil engineering graduate of Bengal Engineering College. Now it is IIEST. He is master's in civil engineering from Jadavpur University and PhD from IIT Kanpur. So he has also done doctorate in engineering from Ibaraki University, Japan, and has been serving NIDM since 2006 as a professor and head of Resilient Infrastructure Division. He served the Faculty of Engineering at IIT BHU, did postdoctoral research in Japan, and was on the deputation to IIT Jammu for some time between 2019 and 2020, where he served as Dean of Students' Welfare. So Professor Ghosh works in the areas of earthquake, geotechnology, reinforced earth, seismic microzonation, ground improvement techniques, geosynthetics, and bioengineering measures for sustainable development. He has devoted more than 30 years of his career in UG and PG teaching, research guidance, development of teaching tools, and training module for engineers, architects, town planners. He has published more than 135 papers in reputed journals, conference proceedings, and as recognition to his seminal contribution, received Leonard Prize for the best doctoral thesis in 1993. So CIDC Vishwakarma Awards he has received in 2013. IGS Shri H.C. Verma Golden Jubilee Award in 2013. Lifetime Achievement Award in 2019 from Indian Geotechnical Society Delhi chapter. So we are really honored to have you, sir, with us today. Thank you so much for giving your precious time to us. And I'm sure participants are also very happy to listen to you. And I would request participants, if you have any queries, you may please post in the Q&A section. And also, so some of the participants were asking for the presentation. So if it is possible for you to share the PPT, you can share with me. I will share with all of the participants.
But participants should see that
Okay,
each and every presentation have been explained in the recorded video. So that will be more easier, no?
Yes, that's what I have told them, that this video is available in YouTube. I have given the link in the chat box. So if you want to go through the slides once again, you may please visit this YouTube link, and that is why we always keep this YouTube link for the future reference. Thank you so much, sir. Thank you so much for being here with us today.
In fact, I think I have taken too much of time.
No, it's fine, sir.
Next speaker. So you have to extend that by half an hour.
Yeah, sure, sir.
For Pranay.
Okay, sir. Thank you so much for joining. Okay, so we'll move on to our next eminent speaker. So today we have Mr. Pranay Das with us. So Mr. Pranay Das is Vice President, Management Consulting practices of Accenture. So he consults all the CXOs of leading organizations on key strategic and organizational priorities. Prior to management consulting, Mr. Pranay worked in Tata Steel and managed one of the largest steel making operations in India. As an operational lead, Pranay ensured workplace safety, health, and ergonomics of more than 100 shop floor executives without any major safety incident. So he implemented process safety risk management and reduced unsafe working conditions involving high temperature, pressure, and amperage. So Mr. Pranay completed his BTech from IIT Kanpur and MBA from IIM Bangalore. So most welcome, Mr. Pranay, to today's program. So the floor is all yours.
Thank you so much, Dr. Shweta. Thank you so much for the warm welcome and the introduction. Thank you so much, everyone. Saturday morning, I know you are out of the busy schedule, investing time in learning what is happening around the world in disaster management, particularly industrial disaster. Thank you so much for joining today. Let me try to share with you the learnings, the work that I do with the clients that I serve globally. I would like it to be an interactive session. Please feel free to ask questions, and let's see how it goes.
Before you start, Mr. Pranay, I would really like to request you, if you can please open your video so that we can click few photographs.
Yes, definitely. I'm trying to share my slides. Is it? I don't see the option to share my slide. Is there something you need to do? Yeah, I can see. Yeah, thanks. So yes, let's. We are here. Let's see each other as well. Yeah. Am I visible? Okay.
Yes, sir.
All right. It should work perfectly fine. Is the slide on the visible to all of you? Am I audible to all of you?
Yes, you are. Can you move your slides 1 or 2 so that we know it's moving?
Yeah. Is it moving now?
Yes, it is.
Okay. Good morning. Good morning to all of you. This is Pranay. I work in the corporate sector and work very closely with the industries who are facing the safety related issues. on a day-to-day basis. When I speak, industries, I am talking about both on the industrial side, on the consumer side. Every day there are a number of incidents and work-related causes, accidents that are happening. And what is very surprising is that most of the work-related deaths and incidents and fatalities are centered around the Southeast Asian countries. And this is something of a concern for all of us, because we need to also have the behavior, the systems, the processes, the design improved in this part of the world as well, so that the number of incidents related to safety also reduce over a period of time. With that endeavor, I would like to share with you, the approach that we typically take when we are addressing a safety issue in a holistic manner. The approach that we typically take is, first we would need to look into the design of any system that we are, would like to improve upon. We would look into the processes that goes into making, the use of that particular design that has been designed for. We see increased usage of surveillance, and to our benefit, surveillance has helped in reducing the safety incidents to a greater extent. But we have also taken a step ahead in terms of how digital can help in, simulating, identifying, proactively reducing some of these safety related disasters. So let's go through each one of these modules and try to understand, what all this entail, what I'm speaking, how this has been implemented. All right, so let's get going. The first thing that I'm going to talk to you is about the design. When anything comes up, the first thing you need to keep from a safety perspective is that, is it going to fail? Is it designed to succeed? Is it designed to fail? Because if the design itself is flawed, no matter of surveillance, process, digital analytics is not going to save it. So that is the first thing you need to solve about. So that, let's look into the first thing. Typically, this is a very old concept, and many of you would be aware of this. Typically, when we say, an incident converted into a fatality or an issue, it's because, when it has passed through the barriers that has put in place to stop it from going to the next level. We would like to put barriers like, a better design, a better process, a better surveillance, so analytics to prevent any kind of incidents to convert into an issue. This is your typical Swiss cheese model. Now, the first thing, as you can see, is about design. A poor equipment, a poor design, a poorly designed car or a refinery will never be able to create a safe working environment. So there are some ways you should be able to overcome this. What are some of these ways? There are and because of this, because of poor design, many such accidents have happened in history. Be it Bhopal, be it England strategy, a disaster, be it Phillips 66 Houston tragedy that has happened. All this happened because of design flaws. Of course, there are understanding flaws, people flaws, but major was the design flaw. So what was done to improve upon the design? There are two things that are done when you try to improve upon a design. One of the very, very popular approach is called FMEA. It is called Failure Modes Effects Analysis. It is a proactive way to identify how a component failure can lead to an overall design failure. When what I'm trying to say is, if there is a nut, if there's a bolt, if there is a corrosion in that, if there is a sealing, if there is a corrosion in that, if there's a heating in that, if that fails, how does the overall equipment or the, the module fails? This is the first approach we took around 1960 when we wanted to understand failures, industrial failures. In fact, this was designed when we were launching the Apollo missions to understand how will a rocket fail, how many ways a rocket can fail if we launch it. And then it has been used in refineries, it has been used in auto industry, it has been used in even today in airports, in any design aspect when you're creating one. So there are various versions of it now, but essentially it is to identify if a failure will happen, how it will happen. To give you an example, what you would see on the right hand side is one of the world's largest geothermal power station. What it takes is, takes the heat. Sorry. Is there a question? Please feel free to ask. sorry, I'm not able to hear properly.
Actually, we want to hear you properly. Some interruption.
Okay, just a second.
Please check your network once.
Let's switch. Is it any better now? Am I audible now? Is it is the streaming better now? Let me do one thing. Has this improved a bit now?
Yes.
Okay. So what we are doing now is to see an illustrative example of FMEA into a power plant. So this power plant was one of the world's largest, and we wanted to understand if there would be a failure because of the design. And for us to do an exercise like this, we would need to understand the components that go into a particular module, which can fail in multiple manner. Could be like the seals, the diaphragm, the rotor blades, bearings, rotor itself, and casing, and understand what are the various ways of failure. So there's a detailed exercise that engineers and designers do, which is called a Fme analysis. If some of you are interested, we can go through that to identify in what way seal can fail. It can fail through corrosion, heating, normal erosion. And if it fails to one of these media, what is the impact? And what is the ultimate, disaster that may happen? And basis that, you try to create proactive steps. So this is one kind of a disaster management strategy that you embed into the design of the units and modules that we are doing. The other kind is called FTA, which is fault tree analysis. This is more advanced. What it does is, it is the reverse of FMEA. It says a failure will happen always. That is, the question is how it will happen. And this is a backward looking logic where you try to assume a failure will happen and try to identify events and that are happening, and what are the causes that are leading to that. These causes typically are not one cause, or it's typically a culmination of a 2-3 causes which lead to an event. These event could be micro event, event could be major event, and some of these major event could lead to a problem. The way it differentiates, or the reason fault tree analysis program was required, is because FMEA is always a component to a module, and it may not create the full picture. And this FTA is more advanced, and this was created by Bell Laboratories when they were trying to create this intercontinental missile systems. All automotive companies, defense systems, use this kind of a model to create their industrial designs. What it does is, it takes again, it's applied to power plants. When you're designing them, if you have to create a power plant, you have to assume the power plant will fail. And the power plant can fail because of many reasons: boiler superheating not happening, your forced draft fans not working, economizer is not there, air heater is not working. So what is it that you need to create is to take a failure, as a failure of a turbine, and identify, could it be because of hydraulic, could it be because of condenser, could it be because of boiler, and if it's because of boiler, how many ways a boiler can fail. So you create an iterative logical tree below this, and then what you do is to create a combination of logics. Is the combination of two leading to a failure, or combination of one leading to a failure through and an OR gate? It's a very Boolean logical diagram that you create, which ultimately tells you what kind of a basic event, small events. A level of water in a turbine can lead to a turbine failure, right? Small events can lead to a disaster. And these kind of disaster identification is going to help you create, identify, predict, establish the probability of causes which can lead to a mega event failure. These two approaches, FMEA and FTA, are the fundamental building blocks when you're trying to create an industrial safe environment. And this should be the first thing you should review. The second thing, the second approach, once a design is to be built once in a while, once a design has been built, the second approach that you should be taking to manage an industrial safety is the process. You can have one of the world's best designs, but it may not be operated in the most optimal manner by the people who are operating it, or by the logics that have been designed to operate it, and it may lead to fail. There is nothing wrong in the design. In those cases, it is even more complex to identify what combinations of events can lead to a failure. I'll give you an example of this, how this is done and how this is mitigated. So a very advanced launch of a lander vehicle which was done in Moon, which was done in Mars. What happened is, we have a Mars polar lander vehicle. When we sent it to the Mars for the first time, we understood that each of the 3 pegs of the landing gear need to have a sensor to identify have you landed or not. All the equipments were working perfectly, and they were communicating to the Earth perfectly, but there was one flaw. There is a Hall effect, which we realized later, which tells the sensor that the instrument has landed even before it's landed. The Hall effect is a temporary phenomena which can last for 2 to 3 seconds and is a spurious signal. The process that was designed, or the software on which the process was running that was designed, was not able to isolate the spurious signal because of Hall effect when the object or the satellite was landing in Mars, and was able to shut off the engine quite close to 40 meters above the Mars surface. Everything worked perfectly. Because of a wrong understanding and a process failure, the satellite crashed, landed into the Mars. So what I'm trying to say is, if your design is good and you don't understand the operating condition of how it's going to behave when it's going to land, and don't understand some of the phenomena like, the landing gear, may sense that the landing has already happened through a spurious signal and cut off the engine. These kind of scenarios are prevented by methodology, what we call it as a process safety risk management. What it does, it takes simulation of the operating conditions and tries to identify what are the weaknesses in the existing logics that have been built in operating a certain design. You will see a more demonstration of that and what we are trying to do. We are trying to solve problems like this through something called as a digital twin. I will show you how a more advanced technology is deployed in a digital twin to understand its phenomena before it's really created in the real world. So this is the process part, how once your design has been made, you have to evaluate the process and have a robust process to operate a certain design. Now, the third thing is, now everything is there. This is another example of, dynamic steel loading. This is a very industrial case, and there is a real life example. We ship a lot of coiled steel through the roadways, so rail and through the roadways. Now, each of these trailer has a certain limit. Typically, they have a limit of, say, 40 tons, 50 tons. Coils that are also loaded in this are also having it, weight close to that, say 40 tons, 20 tons of each, 44 tons of 2 coils. We have seen increasing incidents of shipping steel coils through roadways. It typically topples whenever there is a bit of a movement in the coils. What we understood is, one of the reason is that there's a disaster happen on the roadways when you're trying to ship it, is not because of the weight of the coil, is because of the pent up energy that is there in the steel coil, because it is rolled. It doesn't want to stay in rolled condition. It wants to strengthen itself, but you have deliberately kept it in a rolled condition, and that creates dynamic forces in the steel coil on the truck when the truck is in motion. Generally, a normal, shipping environment of a shipping department doesn't understand these forces that are acting on the vehicle because of a very high potential energy, which is trapped using straps in the steel coil. And and everything is the design and everything is okay, but because of this many failure has happened. So again, many mathematical models have been run to identify what is the pent up energy in a steel coil, how to reduce that pent up energy, so that even when you're taking a load which is much lesser than the steel the coil load, the failure shouldn't happen. uh, I'll take you to the more, evolved area. I told you about design. I told you about process. I will tell you now about, surveillance. Now, with the advent of digital, with the advent of AI, as Professor Ghosh rightly, explained to us, you have a lot of avenues to identify a propensity or an incident before it becomes an issue. And today, every advanced safety site has lot of recognition pattern: people recognition, crowd, traffic, plate, hazard activity determination. If a person should not be there where he should be, all these activities are today being identified through image analytics and deep learning. This is just to prevent, that despite having a robust design and despite having a robust process, there should not be a, there should not be a human enabled activity or a human led, activity which can lead to a disaster. One of the example, as you can see, is, now we see AI and deep learning everywhere, is, the typical industrial accidents that happen in ports, in shipping department, where the vehicle should not be where it should, they are where the designated places and the designated number of, vehicles which can enter a certain port at a given point in time, and they should be stopping at certain places. You're dealing with complex logistics, and if they don't follow the rules that has been defined for them, it can create industrial disaster. What you can see now is every vehicle, like, Tata Steel, Jindal, Ashok Leyland, they get 300 to 400 vehicles every day. A strong discipline is established in terms of who is going to be where at what point in time. They are not doing any activity which is outside the, the safety domain, and all this is to monitor the safety behavior, of vehicles, people within the, risk zone, industrial risk zone. So these kind of activities or these kind of surveillance have helped us reduce incidents to a greater extent. If my voice is audible to any of you.
Yeah, now it's audible.
Okay, okay, okay. So what we do is, we now do blasting assessment in a much better manner through use of, aerial surveillance using drones to understand, did we use more amount of dynamite or less amount of dynamite? Is our configuration of dynamite was okay? Did we blow up the structural integrity of the mine, or we have preserved it? So these kind of assessments are better done in the, in the industrial space now with more aerial surveillance. Using aerial surveillance in India as across the world and across the world, we are also able to look into, what are some of the operating condition, and what is the asset integrity of this. For example, on the left hand side, you can see in a refinery, if the temperatures are increasing beyond a certain limit, we can keep an eye using our RFID cameras, which in at points which are not accessible easily, in pipelines which are not accessible easily. If there's a crack in the cement concrete structure in an industrial setup, we can identify it through high resolution cameras. We can monitor chimneys better, if the chimneys are operating better. Most importantly, pipeline corrosions. For one of the biggest reason for industrial disaster is pipeline corrosion, and now there you have vision analytics to identify the amount of corrosion that has happened, and what is the residual life. So these kind of technologies now help in the third aspect, which we call is it a surveillance. So if you survey properly, if your design is good, process is good, you're not surveying, it will lead to disaster. And through this advanced surveillance, you should be able to manage many of these disasters. Just like over here, you are able to identify what is the green patch that is there in any of the mine, and over here you are able to identify if the people are following the right kind of behavior, and the people are following different kind of architecture for doing the surveillance. Surveillance has become so important, in the today's environment, that it can help you it can help a unsafe place into a safe place for human habitat, to the extent that I will take you an example of Fukushima. We had an industrial disaster in Fukushima, and a nuclear disaster, and many of you would know about it in Japan, because of an earthquake, and because of the radiation, because of many risks that were identified, people left Fukushima, industries left Fukushima, people left Fukushima. It became a barren city. Now, how do we use the power of surveillance to help identify uh, risks in advance and make a sustainable living? So let me give you an example of what the work was done in Fukushima to make it to regenerate life back to the city, and and help it make a safer place.
Is there any sound as well? Because we are not able to listen to any sound.
ここには新たな産業を作る必要がありました。データに基づく
Okay. Are you able to see my video? Were you able to see my video?
Yes, we were able to see.
Okay. I thought only the screen is visible. Thank you so much.
Devices to share with administrations, companies, and educational organizations. It transformed into a large-scale open innovation project for the whole area of Fukushima. For example, a citizen's portal site using AI. Data scientists, wearable devices in healthcare, inbound promotion, and partnership with Amsterdam. Established a citizen-centric model with industries, universities, government, and citizens as one. As the result of 7 years of action, and Fukushima has come back to life. 結果としてデータを扱う先端 ICT 機能が集まった ICT ビルが必要になりました。A new base was built with 250 members. Efforts were awarded by the country as an ideal smart city model. Now, this model is drawing nationwide attention and to expand our service area. We continue to support Finland and Japan.
So, so this is an example of how we were able to revive a city which was deserted by the people through after an industrial disaster. I will show you an example of another, image analytics led revival of ecosystem, which is again under a severe threat, and how AI and image analytics is helping it over there. So this was the first, this is the third part of it, So basically we saw the power of a better design. As a scientist, we need to ensure that we saw a better process. We saw, digital AI image analytics helps today in a strong way to do a better surveillance so that a disaster is averted. But there is more. There is more, in terms of, how digital can help us in preventing this. Some of the other case studies, which we can also discuss in detail is how Chevron has, taken digital in their, in their industries and help prevent industrial disasters through crane movement. As you would understand, the rail platform on which a crane moves is common for most of the cranes, and they can collide. And people are working in a high strenuous environment. How would you ensure that the cranes and the forklifts are operating below it operate in a seamless manner, but at the same time they don't collide with each other? So these kind of industrial incidents are very common, and people are working towards having smart equipments which can solve these problems. So is the area of, how a digital system can be created so that there's a digitally connected worker safety system where, if there is any incident that has happened to one particular person, it is notified urgently to the control center. I'll take you through an example of, the final part of how, digital is helping people over here in managing disaster. It's through an example called as a digital twin. And digital twin, instead of doing a unsafe, so there are kind of unsafe behavior, and then there are unsafe conditions. Unsafe behavior you can solve through surveillance, but unsafe conditions you cannot solve. For example, you have to explore the depths of the ocean. It's a very high pressure environment, and there could be a dynamic pressure environment, and there could be a failure of the pipeline which can lead to a disaster in the oil rig. How would you prevent or operate in an unsafe condition? And that is where digital twin comes in. What can happen is, instead of having a real rig or a real refinery or a real machine, you can have a virtual machine, and you can identify all the things that you would like to identify about the environment using that machine. But we call it as a future where you will have digital twins to operate upon the same conditions that a real machine will be operated upon. Let me explain you through an example. So this is again an example of a machinery, a very, this is a frigate where we are using multiple technologies. We are using IoT, we are using machine vision, sensors, to create a environment which is almost the similar to that of a real life. These are all the architectures for this, but ultimately what it leads to is a frigate a warfare machine, which has to be extremely reliable, and you need to know how it's going to operate in a difficult situation. Using the various simulated environments that we are able to create.
Welcome to the ANZ prototype battleship engine. Here, you will be able to operate and manage, and various equipment data is available to you as a new account. We just received an alert that the engine has overheated due to the movement inside. Reports came in that the generator is overheating due to this problem. Quick, head over to the command console so we can get to the bottom of this. Great, you're here. Let's get cracking. First, we need to engage the cooler pump by pressing the required button on the console, placing the levers on and off. Now we need to shut off the engine. Again, press the required switches and then hit the big red button. Hurry! Wow, that was well done. Next, we have to replace the air fuel filter. You need to open the drawer and pull out the old filter. The new filters are in the back of the engine. Go look for them. When you head over and okay, almost there. Let's restart this engine. Now we need to disengage the secondary fluid.
As you would have understood from this, today we are in an environment where we are able to simulate the entire environments that are going to happen in a real life scenario in an artificial world. And this has also helped in training, the people who are going to be operating on these systems and, minimize any kind of safety incidents or, safety hazards that may happen in an industrial setup. So with this, I would pause and I would summarize that you would have seen from a design perspective, we need to have a design which is validated through a scientific means, through fault tree analysis, through FMEA. Any advanced piece of equipment would do that. The second thing is, despite having a very robust design, it can lead to failure. So you need to have an idea about in what condition and what process failures can lead to do that. And the third thing is, then you need to increase vigilance, surveillance, of the areas where these are operating through digital image analytics, deep learning. And the final thing is, It is now, it's for critical pieces of machinery. Before actually making it using the robust design, you actually do it in a virtual environment. We call it a digital twin of it, and simulate it for various kind of failure conditions. This not only proactively helps you identify what may happen in a real life scenario, so that incidents like Fukushima, incidents like 3 Mile Island, incidents like, all the nuclear industrial disasters don't happen, and also train the people what needs to be done in a condition like this. That's all I had for me to share with you. I hope you liked it, and please feel free to ask me any questions that you may have on your mind. Thank you so much.
Thank you so much for your preparation. You have vividly explained all the processes that we need to ensure for making our systems safe, because industrial safety is really a matter of concern, as all of us know that in recent past also we had many of the industrial disaster incidents, especially in the oil industries and also some small industries. And the difficulties were very simple, like somewhere we didn't have a proper place for fire brigade to enter with a very small industry. Mostly they do it in a place wherever it is easily available or cheap. So those all things are there. And as you mentioned, that transportation is a big problem, because whenever we are transporting a hazardous material, and if the uh, you know that machine or that entire car topples, then it is hazardous. So really wonderful deliberation, Mr. Das. Thank you so much for giving your precious time to us. And thank you for this wonderful presentation. You have taken help of lots of videos which explains the detailed complex processes. So I think there was a question for you. Will you be able to take it up, Mr.
Yeah,
Das?
definitely.
So so the question is, sir, can you please explain what exactly happened in the Chernobyl disaster and what flaws led to it?
Chernobyl disaster is both a mix of human. It's a very good question. It's very close to my heart. I'm a nuclear engineer also. I've done courses in nuclear engineering. It is a very unfortunate incident. You know what happened? Before the Chernobyl disaster, you have to understand there was a shutdown that was taken. In the shutdown, there were some mistakes were done in terms of the sensors. So the mistake that was done is if you push a PLC button in your dashboard for an open command of a D2O, which is heavy water, it should open and discharge the water, and if it's a close button, then it should release the water. Because of certain reason, that logic got flipped during the during this shutdown, and no one was aware of this. The plant was working fine. Now, in one fine day, what happened is the temperatures within the reactors were rising. When temperatures within the reactors rise, what you do is you put in more amount of D2O, which is heavy water, into the reactor. Most of the reactors at that point in time were heavy water. Today, you have pressurized light water reactors. Now, in a heavy water reactor, when you are giving more amount of water into the reactor, the temperature should come down, or you put more amount of cooling rods into that. What happened is, because of this reverse logic, the actually temperature shot up, and the engineers in the room were not able to understand what was happening. It is because during the maintenance, the logic got flipped that create amount of chaos. And because of this, more number of decisions were taken. There was a reservoir. With the reservoir, water was flowed into that, and ultimately what you would see is, because of any limited process safety design intervention, and because people had to take decision at the last moment, we could not control the temperature within this reactor, which led to reactor meltdown. And because of the reactor meltdown, the explosion happened, and the radiation got leaked. So, today it will not happen. In any nuclear power generating station, there is a huge amount of controls in place from a design, from a process, and these are made what you in industrial term you call foolproof. Even a person who has no understanding of the reactors would be able to manage it. This has been like, most of the systems are now auto guided. So it will not happen, but it was not there at that point in time. And even you saw that India's case, right? There was a missile silo and they took a maintenance. During the maintenance, one missile got launched and fell in a neighboring country. It's an unfortunate incident, but maintenance should be done by people who knows it well, and you generally overhaul, take down all the systems, put it back. There could be mistakes, and mistakes like Chernobyl has happened in other places, not in a nuclear setup, where open and closed hatches logics have been reversed for some mistake, due to some mistake, and because of this human mistake, this incident happened. Any other question by anyone? Am I audible to all of you?
Yes, Mr. Pranay, you are perfectly audible.
Yeah. So feel free to ask any questions. See, I think surveillance, has reduced the lot of these industrial disasters. Still, it happens. When I was in my industry, I worked in Tata Steel. So the surveillance part is what humans used to do. So every week I had a certain target that I will survey my area and others area to identify what issues are happening. Today I think machine has taken over. You don't have to do it manually, because machines can do it through various visions, deep vision. They can identify, spot even the remotest of crack, which humans cannot do. So I think machines are taking over humans in the surveillance part, but where we need to play an active role is the digital twin and setting up the unsafe condition virtually, and identify in how many ways it can fail and make ourselves as a safer place. As you would understand, the Fukushima example is important because it's a very deadly place. No one wants to go there. But even in that, there is a thriving city operating now. And if you are able to have proper systems, surveillance, and disaster management practices in place, even an unsafe condition can be made into a very hospitable living condition. With that, I would like to pause and sincerely thank you for joining and spending this call today and spending your Saturday morning. I hope it's spent, it's a time worth spending for all of you, and you had a useful session. Thank you so much. It was an honor to join the session and share my experience with you.
Thank you, Mr. Pranay. I guess the host has again facing some technical glitches, but on behalf of her, I would like to thank you for your very interesting and very interactive deliberation, and the way you answered this question, and you in fact gave a the exact explanation of the what exactly happened behind that. So very interesting, it was great to hear from you. So thank you so much, and thank you so much for delivering your lecture in the webinar today.
Thank you, Gopal. Thanks to all entire team in NIDM for making it possible. Thank you, all the participants. Thanks. Bye.
Good afternoon, everyone. I'm really sorry that I'm facing some serious issues in my system today, some serious technical glitch. I'm really sorry for that. But now I would like to request Dr. Kopal Verma, who is an expert in atmospheric chemistry and climate resilience. She has done her PhD in mitigation of indoor carbonaceous aerosols in rural areas from JNU. She has been conferred with NESA Junior Scientist of the Year Award in 2018. She is the alumni of prestigious European research courses of atmosphere from Grenoble, France. She has publications in various journals and articles. She has deeper interest in sustainable waste management, and apart from all these, she has also a meditation and life skill trainer. So most welcome, Dr. Kopal, and I would like to request to kindly proceed with your presentation.
Thank you very much, ma'am. First of all, for inviting me for this webinar. And can you please give me the sharing rights?
Yes, I have given him.
So, as I already mentioned, the previous deliberation was very, very interesting, very interactive, and obviously listening from Professor Chandan Ghosh sir is always it's always so good because he is an ocean of knowledge. So it's always so great to listen from him. So, in fact, a very interesting webinar is going on, and I am happy to contribute to this. Just give me a moment. Is my slide visible? Can you confirm, ma'am, please? Okay, so I hope my presentation is visible to everyone. So since we are talking about industrial safety and chemical hazards, chemical disaster management, so I thought to give an insight about the safety side of that is to be taken care in the chemical industries during chemical hazards and all. So, just to give a brief introduction, there are almost 3.5 lakh industries registered factories in India that is working, and I'm sure this is not the actual number. The actual number is much, much higher. And out of which 6,000 and 6,000 units are undertaking hazardous processes. They are dealing with hazardous and toxic chemicals. So these kind of chemical and allied industries, it is one of the fastest growing segments in Indian industries. And dealing with chemicals is very, very difficult. Like its entire lifetime, like the right from its manufacturing to transport to its utilization, it has got so many inherent properties, and it is capable of causing so many hazards. So it is very important that when we are considering, when we are dealing with a particular chemical, we should take care of its entire life cycle, right? So chemicals can be of many nature. It can be flammable, explosive, toxic, corrosive, and so on. So, and from our past, and our past has taught a lot regarding how these chemicals, a very small fault in our system, be it a man-made, be it the fault from the human side, be the fault of machinery, a slightest fault may cause a disastrous uh, hazard, disastrous mishappening, you can say. And Bhopal Gas Tragedy and very recent Vizag LG Polymers gas leak. So all these are a very, very big lessons for us to learn to deal with chemical accidents. So this is a very short scenario, although I am talking about it's only in 2020. That is the scenario after COVID-19 lockdown, because during the lockdown, so many industries, they had to be shut down all of a sudden, uh, and many people, what many, but almost all of the people were not aware about the shutdown process, because nobody expected this kind of sudden shutdown, sudden lockdown. So thing one was that these industries had to undergo a sudden shutdown, and once the lockdown started to lift up, uh, these industries again have to open up and again have to start their functioning. But when a particular unit is closed down for such a long period of time, there is a particular procedure, there is a particular protocol that should be followed to make it running again. I think my so I will be closing my video. Yes. So you can see here, only in 2020, so many chemical industrial accidents have happened, and it has even continued to year 2021. And very recent gas leak at Sachin Surat has also happened in this year itself, and it is continuing. And for those who are living in Delhi, you all must also be aware of this Bhalspa landfill that is on fire from past 3 days. So this is a very, very um, frightening situation, I would say. So you can see here, this is a very limited data of only a few months of the year 2020. And it's very important to go through this data, because this is the time when the industries were coming back to their normal functioning. And you can see here so many accidents in almost all of the states, and especially Gujarat and Maharashtra, because so many industrial units are present in these states. These chemical industrial accidents have happened, and this is around 25 accidents have happened in such a short span of time, causing so many lives. So mortality is this much, but the casualties, people getting burned, people getting affected by it, the number is really, really high. And you can also see here that this number, India is sharing the highest number when we are talking about global deaths that are related to industrial accidents. So now I would want to talk about the globally harmonized system, GHS. So in order to ensure safety, in order to ensure um, that a particular chemical accident or particular chemical mishappening doesn't turn into a catastrophe, doesn't turn into a disaster. So that's why some systems have been placed. So this particular globally harmonized system, it is not a regulation, it is basically a framework. So from which competent authorities may select the appropriate harmonized classification and communication elements. So a particular industrial unit that is dealing with a particular chemical, so they go through this set of system, so that first of all, they are very well aware of a particular chemical that they are dealing with. They are very well aware of its entire life cycle, and that they are also able to communicate to others who have to deal with this particular chemical in future. So competent authorities will decide how to apply the various elements of this GHS within their systems based on their needs and the target audience. So entire system has not it's not necessary to be applied everywhere, right? So GHS includes basically two elements. So first is the harmonized criteria for classifying substances and mixtures. So this element includes entire information about the particular substance or the compound that the unit is dealing with, its health hazards, environmental hazards, physical hazards that these substances are capable of causing. Then harmonized hazard communication elements, including requirements for labeling a material safety data sheet. Um, so any incident of hazard that has happened in past, so that has to be documented, and it has to be passed on to the next to the rest of the employees, and or maybe you can say to the next generation, so that people are well aware that this particular substance is capable of causing this harm. So the next persons who will be dealing with this in future should be well informed about these characteristics and these properties. So these elements of GHS, these are basically the collection of building blocks from which we can form a regulatory approach to deal with. So next is HASCOM. So what is HASCOM? HASCOM is basically Hazard Communication Standard, HCS we can say. So it's kind of a language. It's kind of a language that we talk uh, uh, to make people understand what kind of chemical is being carried, what kind of chemical is being dealt with, and what kind of hazards and injuries it is capable of causing. So that's why this kind of language, this kind of communication has been set up. So first, to protect against chemical source illnesses and injuries, people are aware. And second, the employers and employees, that they have sufficient information to anticipate, recognize, evaluate, and control chemical hazards. And they are also perfectly equipped to take appropriate protective measures. So just imagine such kind of a system not existing. Suppose, because just imagine concentrated nitric acid, like it looks just like water. Suppose it doesn't have any safety sign that it is a toxic chemical is being contained in this container. So what hazard, what kind of injury it can cause. So that explains the seriousness of this situation, and that explains the need of this kind of hazard communication standard that is required. So this information, this HASCOM information, can be provided through safety data sheets, material safety data sheets, labels, and proper training of the employee, right? So we are talking so much about hazard and risk. Are we clear about the difference between hazard and risk? So first of all, these are not at all same. Hazard is something which is the inherent property of that particular substance, and risk is something, it is a probability that that particular substance, how much hazard, how much damage it can cause. So for example, again, concentrated nitric acid, I would take, it has hazardous property of being a toxic chemical, right? But the risk will depend on to how much area it has been spilled, right? So that is the difference between hazard and risk. So a substance will present the same hazard in all situations, but the risk it is posing, it will depend upon various factors like how it is contained, how it is handled, what kind of personal protective measures are being used, and various other conditions. So I hope the difference between the hazard and risk is clear from this. Now, what is hazard determination? So it is a process of evaluating available scientific evidence in order to determine if a chemical is hazardous. So this hazard determination, it undergoes evaluation, and it evaluates the physical hazards like flammability, reactivity, health hazards that a particular chemical may pose. So it provides the basis for hazard information, right? So hazard determination does not involve an estimation of risk, because as I said earlier, it it is the risk is dependent on so many other factors. Although hazard is same for a particular chemical in all situations. So HASCOM particularly aids in hazard determination. So now, who must conduct this HASCOM, hazard determinations? So it is must for chemical manufacturers and importers who are dealing with the chemicals, whether they are producing it or importing it. So it is must for them, and it is a choice for distributors and employers dealing with these chemicals. But I think it is the best option to undergo this, and the procedures used must be described in writing and made available upon request to employees and their designated representatives, because We have learned so much from the past, but until and unless it is documented and it is available for the next generation, that they are supposed to take care of these particular things, it is of no use. Those past accidents will be of no use. They can provide no lessons until unless it is documented and it is made available to the further generations to use it. So that's why the final and the most important step in hazard determination is the documentation. So this is the control of substances hazardous to health. Like these are the COSH symbols. So as I mentioned earlier, it is a part of the HAZCOM, hazard communication. So you see these signs and you are aware that what kind of chemical or what kind of substance is being dealt with, and so you are aware that what kind of care that you have to take, right? So this kind of sign where with a tree and a fish lying dead harmful to the environment, fire is highly flammable substances being dealt, then this is obviously explosive, some self-reactive substances are being dealt, then oxidizing substances. A skull with bone shows toxic or very toxic substances being handled. Then you can see here corrosive substances being handled. This is the a sign for harmful or irritant. And then this is a cylinder. So this shows gas is under pressure. So, and this is the longer term health hazards, like the substance being dealt with this sign, maybe carcinogenic. It is having the possibility of mutations and so many other things. So these signs have helped a lot in taking care of in dealing with particular chemical or particular substance. So last but not the least, I would like to talk about the need and importance of safety audit. So safety audits, they help us identify the vulnerable areas and specific potential hazards to prevent loss. The objective of safety audit is to establish the level of compliance with Indian standards and other statutory norms and regulations. So safety auditing is very, very important and it should be an integral part of any organization safety management system, and compulsorily for chemical industrial units. The safety auditing system should be in place, should be updated, and should be a regular process, especially in the chemical industrial units. So this helps the organization to check the appropriateness of its safety policies. So whether the safety policies for that particular organization are in line, are well updated, whether the organization needs more equipments, no more resource persons, more skills to deal with a particular kind of hazard. And in fact, various hazard scenarios are imagined in the safety audit, and the readiness of the particular unit is being checked, whether the unit is ready for this kind of hazard or mishap that it might happen in future. So safety auditing is a very, very important part for any industrial unit. And yes, so that's all from my side. So I hope with my this brief presentation I could contribute a little to your knowledge. So thank you so much.
Thank you so much, Dr. Gopal, for this wonderful explanation. Important issue in industrial and chemical disaster management. It is indeed really important to raise among everyone in the society, and we can do it various programs or webinars like our webinars. Thank you so much for and for your share this topic. So very briefly, share a little bit of basics, a little bit of basics industrial And actually, some exam made it managed. So, uh, what I want to do that, so what I are doing it with develop and um, there are so every resource is on city. Am I audible now?
Yes, ma'am.
Okay, thank you so much. So basically, I wanted to share what are the basic things that we are facing in all the chemical and industrial disaster management, the very basic problems that we see in every day. Can we move to the next slide, please? Can you please make it full screen? Um, Yep. Yeah, thank you so much. So basically, there are few reasons why we face these things, which Mr. Das has already touched, but let me, recapitulate once again. So basically, it is either human error or technical error or management errors. So those are the things that that we face while we are talking about the industrial or chemical disaster. So why chemical? Because in most of the industries, it is some kind of chemical that we are using, and the things happens due to the chemical reactions. So industrial disasters also include some physical failures like system failure and all. So those Mr. Das has already touched upon. So now also let me tell you that there are natural calamities which can actually uh, you know um, uh, create some kind of disastrous situation. So natural calamities like earthquake or landslide or sudden cyclone, or maybe tsunami if your industry is located in the coastal areas. So all these things actually disrupts the entire system if you do not have a proper plan for management or a proper plan for adaptation. So during transportation also, as we have already discussed, that there are different problems. Day before yesterday when I was going to office, I saw that one milk van that has toppled, and lots of milk was coming out, and most probably the driver was injured in a bad way, because could see some blood stains on the road. So those are the things. It was just a milk van, so it is not much hazardous. But imagine if that car was carrying some kind of oil or other things, so there could be a big fire. And the problem is most of the roads of India are very congested, so you will have some hundreds of cars near that thing. And you might also have lots and lots of important buildings near to the explosion site. So that is the grave situation that we often face. So also we face difficulty when we are processing hazardous waste. Those are coming out from the industries, and the problem comes when we do not know what are the components are there in the waste, because in many of the cases, many of the small scale industries, they might be using some chemicals of cheaper quality, or whatever they are getting cheaper. Then problem comes is that cheaper thing might have contamination of other chemicals which are not desirable. So when the waste material is coming out of the industry, then that waste material processing becomes very difficult, and in many of the cases we see some hazardous situation. And then comes the terrorist attack. We barely have anything to do in this, but then we always have to be careful about our storage facilities, because mostly terrorists and all, they will attack the storage facilities. Therefore it is a problem. Now we have to remember one more thing, that if we have cluster of industries in somewhere, so if suppose Gujarat, so Gujarat or Maharashtra, they there you get a very crowded population of industries. So there, if something happens to one industry, that can have impact to the other impact industries also, if they are closely spaced. So next slide please. You can use the arrow button. Yeah, thank you so much. So we already faced many of the disasters, like Bhopal gas tragedy, or oil refinery in Vishakhapatnam. Please go to the next slide. So I'll not go into the details of those tragedies. You all know that due to some small minor human error, we faced so much of bad situations. So here are some of the lists, though the list is bit older, and where you can see that lots of people have been killed, starting from Colombia explosion to Brazil explosion. But you can see the most thousands of people have died due to this kind of incidents. But one good thing is that if you see the temporal variation with time, the number of people killed are reducing. So if you look into the present numbers, those are much lesser, because that shows that we are aware now, and at least to some extent. And now we are taking some mitigating steps or adaptive steps, which are helping us in achieving this success, that we are able to reduce the number of deaths. Next slide please. So, we get examples not only in India, also from other, nations of the entire world, that various major accidents happen. But the thing is, more we have, uh, you know, uh, adaptive capabilities, because uh, next slide please, more we have the adaptive capabilities, more we'll be able to cope up with the situation. So if you look into this map, you will see that this map shows you the concentration of accident hazard areas. So these are the numbers which will tell you the multi-hazard districts. So red color means the maximum hazardous districts, and towards lighter, sky blue or white, that will tell you the lesser hazard district. So you can see, and also along with that, the lines will tell you that multi-hazard district. So you can see that Maharashtra and Gujarat, they have the maximum numbers of hazards those had happened, or the disasters that we have faced. So basically, Gujarat, we had 537 accidents or disasters, and in Maharashtra we had 347. So one of the reason is that Maharashtra and Gujarat, they are accommodating densely all the industries. Whereas if you look at Jammu Kashmir or Himachal Pradesh or Jharkhand or Manipur, Mizoram, they or Arunachal Pradesh, we do not have much industries there. Therefore, obviously the accident rates are also lesser. But then we have to understand that the situation should look like that we though we have lots of industries, then also this color should grow towards white. So next slide please. Next slide please. So these are some of the recent disasters that we faced, be it in factory or be it NTPC power plant. Next slide, please. So you will see that fire factories, their problem is nowadays, um, sorry, factory fire. What happened is there, it was located in a area which is very densely populated, that is Anaj Mandi. And Anaj Mandi is a place where hardly you have place to enter into that. So the basic problem that was faced by the firefighters were they were not able to take their engines inside those roads. Next slide please. So this is the difficulty that we face normally. So in NTPC also, due to some small fault, over 40 people were killed. And it always becomes very difficult for people. And then we have Shivkashi firecracker factory incident also. The basic problem in our country is wherever there is a firecracker factory, many people work there who hardly knows about the thing. So very young people like of 12 14 years or 15 years, they are working into this firecracker factories, and they do not know much about what they are mixing and what could happen as a result. So earlier whenever we used to buy firecrackers, we were never afraid that it could burst. But I faced an incident at my home itself. A firecracker which is not supposed to burst, that bursted, and my father got injured severely from that. So those are the situations. Because of contamination, we face lots of difficulties. So that is the thing. And then we always see lots of fire events in the oil corporations, those we have in India. And also the latest one that we faced in 2020 in LG Polymers Visakhapatnam, then also it is really difficult. So the people who are responsible for these incidents, they they have already done it, so we can't do basically with them. But what I want to share is, next slide please, that whenever you are keeping a person for the responsibility, like the plant security or plant safety, like you have some gas plant or you have some disastrous chemical plant, there you should ensure that a very responsible person is there, and may what come, they will not leave the situation and they will handle the situation properly. Because due to one person, so many other people, lakhs of people, thousands of people, they are in a grave situation. And imagine about their family members who are dependent on them. So it becomes very difficult, because in all the places you do not have enough health facilities. Like for Bhopal gas tragedy or for LG Polymers, people barely had health facilities in the nearby areas. So then it becomes very complicated situations. So that is why we all should take the responsibilities at our end, so that nothing unprecedented happens. So these are some of the lists that chemical disasters those have happened in past in the worldwide countries. And next slide please. So we also had something in United States. There also 15 were killed in 2005. And in 2001 September, some grave situation happened in France in a fertilizer company, and then 4,500 people were dead. Next slide please. So and also it destroyed 27,000 buildings. So that is most important. 4,500 people is already dead, you are giving compensation, but what about 27,000 buildings? Because government also need to give some compensation to them. And in most of the cases these companies do not provide the compensation, because they will tell that we have already lost our plant and all, we are in a loss, we do not have money, so they will raise their hands. But ultimately government has to provide the compensations, therefore it is really difficult. Though nowadays government has some strict policies and plans for all the industries, but then hardly any of the industries follow them. So this is the thing. So we also had many other incidents, but the Bhopal gas tragedy was the most horrific one, where 5 lakh people were dead due to the toxic gases and byproducts. No, 5 lakh people were impacted, sorry, and nearly 4,000 people were officially confirmed dead. Next slide please. So you can understand that this is not only the case for India, but this is the case for, next slide please. This is the case for many of the countries of the world, be it US, be it UK, or be it other um, nations like France and all. They are developed countries, we consider them to be very dynamic and advanced, but there also we face industrial disasters or chemical disasters, because ultimately some one or two people will be because of some small mistake or some small ignorance, this happens. So that is why ensuring this safety securities, so we have to ensure in a level that even if that person is not careful enough, then also it will not create a mass hazard. uh, can you please go back to the previous slide? Yes, thank you. So in this data sheet, you can see that in Maharashtra itself, we have some 38,150 registered factories, and working factories are 31,000 among them. So among them, you have 3,200 chemical factories. So the most of the factories, those are concentrated in Pune region, and then comes Thane and Raigad region, and also we have few more in Nasik. So it is well distributed in many of the district, but then some of the places are very congested with the industries, therefore it becomes very difficult. Next slide please. So we will always have to be careful that we make sure that the residence area is far enough by strict rule from these industries. Next slide please. Because once these industries are they are facing some this kind of disaster, then the people who are um, there who are staying there, they face a lot of difficulty. Next slide please. Next slide, please. Okay, I'm sorry. So I was saying that there are varied reasons for which you can you know face chemical or industrial disasters. So among those reasons it could be anything, control system layout, fabrication, knowledge base, flow related issues, and so many things. But the most important 3 or 4 reasons are the failure in the piping system. So if you do not have proper piping, it could burst, it could leak. And then management or procedural system failure, that is another important thing. And the contamination, because as I have mentioned, because most of the time we go for the cheaper options, therefore contaminations come into the picture. And contamination always creates difficulty in waste management also in the system. So these are the things. And in the right hand side picture, if you see that how we are exposed to the chemical disasters, so you can see directly also. If you see this round thing, source, so source is the place where the chemical I will say exposure is taking place. And if that directly goes to soil, then also you can get affected, because from soil it will go to crops, and then from soil it will go to animals, then through soil it will go to food, and from food it will go to human being. That could go to the children, that could go to the pregnant woman, that could go to the elderly people, to everyone. Then directly also from the source, that can go into the river reservoir. Okay, and that can ultimately go to the aquifer, and then to the drinking water, and through drinking water also that chemical can come into the people. And also the people who are present in the situation near the source, they can also directly be impacted from the source. So these are the way through which you can you know get impacted by any of the chemical um, exposure thing. So finally, I will talk about the BLEAV. So it is boiling liquid expanding vapor explosion. So basically, whenever you are transporting your chemical material through I will say, like with any of the cars, like engines and all, in most of the cases, there is a chance that it might blast. So it occurs when the catastrophic failure happens of a vessel which is containing, liquid flammable material like oils and other things. And then um, this material is pressurized in a vessel, and whenever some leakage or some transport failure happens, that chamber can blast. And those are horrific things. So if you search videos for believe in YouTube also, you will get to see several videos, and those are really horrifying. Because if, you can always see, whenever you are driving through a road, you can always see, oil tankers are going, and other things. But just imagine if they are blasting, then it is really difficult. So it is always suggested that maintain some safe distance from the tanker if it is moving. So that was my daily presentation for today, and that's what I wanted to share with you. Thank you so much for your patience. I know it is a Saturday and almost entire morning I took. And thank you so much for being with us. And I'm really thankful that you are here with us. And your questions, hopefully I've answered all. So one more time I would like to tell you that whomsoever was here present here for the 80% of the time, you will receive a certificate. But please make sure that you fill the feedback form you will get when you go to the website and you are trying to download the certificate. They will show you an option for filling the feedback form. There itself you can fill the feedback form, and it takes a little bit of time to generate the attendance, so it normally takes 2 days. So please wait for that, and by Monday, if I get the attendance, definitely I will upload that in the website, and once I upload the attendance in the website, you will be able to download your certificate. So there should not be any issues, but in case if you are facing any issues, please connect with the training cell. But normally many people do these training programs and webinars on regular basis, and they are getting their certificates. For some people, we might face a bit of difficulty, but in many of the cases I have seen that people are saying that we are not able to get certificate, but then when I check their attendance is 0%. But then also people say, no, 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 I was there for the entire system. So I will like to tell you that it is a system generated thing. We can't do any modification in your attendance. If you are present there, the system will automatically show that you were present there, and for how much of time it will show us, and we are not able to do any modifications for any of the attendance thing, because if we open that sheet also, then also it will not upload. So it is done so that the proper attendance is there for the certificate. Thank you so much for your patience, and thank you, my heartfelt thanks to you, because you have given your valuable time to us on a Saturday morning. Thank you so much, and have a good day all.